China didn't just stop tracking 3i Atlas for no reason. It went silent right after its telescopes picked up behavior that didn't match the earlier, clean curve of this interstellar visitor near Mars. That timing made astronomers ask, did China simply run out of telescope time, or did it see something strange and move the data behind closed doors? In this video, we trace that silence, the technical explanations, and what it tells us about how strategic deep space astronomy has quietly become. 1. China's early sprint. China's opening response to 3i Atlas was fast, confident, and surprisingly open for a country whose deep space assets are usually tightly scheduled. In late August, while the object was still inbound toward Mars, the Purple Mountain Observatory shared internal notes in Chinese channels saying that the orbit they were seeing was hyperbolic, in other words, not bound to the Sun. At almost the same time, the National Deep Space Network began pointing both optical telescopes and its big 35-meter radio antenna in Xinjiang at the object. That alone tells you this wasn't treated like a random comet. China pulled in multiple sensors early, which is what you do when you want to build your own independent solution and not rely only on US or European ephemerides. What strengthened China's case is that its numbers lined up with other Asian observatories. Japanese astronomers using Subaru and Indian astronomers at Ares were also reporting positions and brightness that matched an interstellar body. When 3 different systems, in 3 different countries, agree on an object's motion, the confidence goes up sharply. That was the moment many trackers said, okay, this really is the 3rd confirmed interstellar object after oumuamua. Whoever stayed on it during that Mars window would capture the best science. China then did something everyone liked. It posted refined trajectory data to the National Astronomical Data Center. Those updates said the closest approach to Mars would come in the first days of September and warned that, from Earth, the object would soon move behind the Sun, which makes optical work much harder. That public posting helped non-Chinese observatories keep their instruments pointed correctly. Up to that point, Beijing looked like it wanted to be seen as a responsible, high-speed participant in a global discovery. Then came the odd part. The last public dataset from the Xinjiang 35-meter dish showed a signal that faded faster than expected right before the geometry worsened. A drop like that can be innocent. The object could have rotated, a dusty jet could have changed its reflective area, or solar background could have swamped the dish. But the timing matters. It happened just as 3i Atlas was reaching the high-value Mars phase. That is exactly when you would normally keep collecting and publishing. Instead, the Chinese public stream stopped. Because everything had been so active and so transparent up to that point, the sudden quiet looked less like we lost it and more like we moved it somewhere else. 2. The Mars flyby silence. When journalists and foreign researchers noticed that no more 3i Atlas observations were appearing on China's National Astronomical Data Center after the Mars window, the official answer was straightforward. The same antennas and telescope time were needed for Chang'e-7 lunar mission preparations and for Queqiao-2 relay calibration. That is a logical explanation. China does not yet have endless deep space capacity. Large dishes, especially in Xinjiang and Kashgar, are booked to support lunar South Pole operations, spacecraft ranging, and sometimes even tracking foreign probes. If 2 national priority missions are in test or calibration, an interstellar visitor, even a rare one, can get bumped. That part matches what the CNSA spokesperson said. But the problem is not that the explanation is impossible. The problem is that the timing of the silence sits uncomfortably close to the most valuable scientific moment. The last Chinese data we saw was right before the object moved behind the Sun from Earth's view and right around the expected closest pass to Mars. If the gap had come a week earlier or 2 weeks later, no one would have raised an eyebrow. Coming right there made it look intentional. There is another layer that Chinese researchers themselves sometimes mention anonymously. Some deep space data streams are now classified automatically when they overlap with frequencies or stations that are also used by strategic users. China's TTNC system is strongly civil, military fused. A center like the Xi'an Satellite Control Center can be supporting a civilian astronomy task in one slot and a defense-related tracking task in the next. When that happens, the easiest way to stay safe is to move the whole observation, even the harmless astronomy part, to an internal archive and stop mirroring it on public science portals. From the outside, it looks like China stopped tracking. From the inside, it can look like China kept tracking but stopped showing it. We have seen a similar pattern before. During the fall of small objects like 2022 WJ1 over North America, parts of the trajectory were shared internationally, while other parts stayed in national systems because the sensors that saw them were doing something else at the same time. That tells us this is a known workflow, not a one-off mystery. The most realistic reading of the Mars flyby silence is this. Chinese assets almost certainly kept watching 3i Atlas, but the data moved from the public science-friendly channel to a protected, mixed-use channel the moment it became sensitive, either because of the frequencies involved, because of the pointing schedule, or because someone decided that interstellar tracking has strategic value. That is very different from "we lost the object." 3. Why the silence matters. At first glance, this might sound like a small story. One country paused public updates. Others kept observing. The object is gone. End of story. But for astronomy, it is a bigger signal than the comet itself. We have only ever seen 3 confirmed interstellar visitors. Every single one of them is precious because each gives us a direct look at material that formed around another star, in another environment, probably billions of years ago. We cannot send a probe there easily, so when one of these objects passes through our neighborhood, we have to squeeze every last bit of data out of it. If even one capable nation with excellent antennas decides not to release its part, the world's total understanding becomes thinner. Scientists like Avi Loeb have said this very clearly in interviews. When observations disappear, certainty disappears with them. If 3i Atlas had a moment of unusual dimming, or a slight non-gravitational push from outgassing, or a change in color that hinted at uncommon ices, we need multiple, independent groups to confirm it. One dataset can be an instrument quirk. 3 datasets, from 3 countries, taken at the same time, that becomes evidence. China's early participation was valuable precisely because it added a second voice from Asia to what ESA and Indian facilities were doing. When that voice went quiet, the rest of the community had to infer instead of compare. What makes the case even sharper is that Europe and India did continue. ESA's Mars assets, ground telescopes feeding the Minor Planet Center, Indian optical stations, and even some amateur networks kept updating the orbit and brightness. That proves the object was still observable and worth following. So this was not a situation where the whole world had to stop. It was a situation where one major player chose to stop publicly. That choice turns 3i Atlas into a textbook example of what we might call cautious astronomy, science that is technically possible to share, but politically or strategically inconvenient to share right away. And that has consequences. Interstellar objects are becoming a prestige field. Being first to detect, first to model, or first to propose an intercept can translate into funding, soft power, and leadership in planetary defense. That means countries will sometimes prefer to hold their highest quality data for internal analysis before releasing anything. If that becomes normal, then future visitors, maybe the next oumuamua-like object, will arrive in an environment where data is tiered, a public layer for media and collaboration, and a private layer that only national centers see. The risk is that scientific debates will be based on incomplete material, which slows everyone down. The lesson from this episode is simple. If the world wants to learn everything it can from rare, fast-moving interstellar objects, then observation rules have to be agreed before the object shows up, not improvised during the closest approach. Otherwise, we will keep getting exactly what we saw with 3i Atlas, a brilliant start, a mysterious gap, and a lot of people wondering what, exactly, the missing Chinese data might have shown. 3i Atlas didn't just test our telescopes, it tested our openness. China's sudden silence showed how fast deep space science can become strategic. If we want the next interstellar visitor to tell us more, cooperation and fast data sharing must come first, before politics, missions, or national priorities. If you enjoyed this video, please like, share, and subscribe for more space updates. Your support means the world and keeps our journey going.